We know that bode plot is used to find the stability of the system and also used to analyze the system and to design the system. Let us say for any given specifications we need to design what will be the amplifier gain. So this is one kind of the design problem. Now so here we will see how to find K value using bode plot for given specifications, frequency domain specifications. So usually the specification which are important are the gain margin and phase margin. So how can we do that? For any given margin, for any given phase margin, given gain margin, then we can adjust the magnitude plot. When you adjust the magnitude plot, then we can have the variations in the gain crossover frequency, and we can easily find what the required K value. So it is completely a graphical method where we are adjusting the magnitude plot. What are the steps to be followed? The first one, procedure to find K value for any specified gain margin. For any given gain margin, how to find K value? So a simple two steps procedure. So in the first step, we will try to find what will be the required MdB that is to be modified. The amount of dB to be modified in the magnitude plot, that we need to find out first of all. So that I am writing it as MdBr. MdB required, M for magnitude, dB is magnitude in dB, R is required. So MdBr is equal to, so gain margin specified, what will be the gain margin that is specified, minus what is the gain margin when K is equal to 1. So when K is 1, we will find the gain margin, because the entire bode diagram can be drawn when K is equal to 1. When K is a variable, we cannot draw, so K we can take it as 1 and we can draw. So after that, what will be the gain margin? When K is 1, what is the system gain margin? What is the specified, what the user want? Then the required MdB R will get it. So this is the first step. The second step, we can directly substitute the formula to find the K. So 20 log K is equal to minus MdBr. 20 log K is minus MdBr. We use minus because we know in magnitude plot, if MdB is negative, the gain margin we take it as a positive. So in that way, 20 log K minus your MdBr, if you solve for it, you will get the K. This K is of the system for the specified gain margin. Similarly, we'll see the procedure to find K value for any given phase margin or specified phase margin. So in this case, we look at three steps. The first step is going to be, we know the specified phase margin. From the specified phase margin, what will be the required phi GC? The phi GC is the phase angle of GH of j omega at gain crossover frequency. So if when K is 1, then we can find out in one direction, that is you find out what is omega GC and take that at that frequency what will the phase angle, that phase angle is phi GC. But we need to go in a reverse direction where we know already the specified phase margin. So what I can do is, in this formula, phi GC required, phi GC R is equal to phase margin specified minus 180 degrees. Therefore you will get phi GC R. In the second step, locate where the phi GC are there in the phase plot, and at this particular phi GC, what will be the magnitude? So at that frequency, what is the magnitude we need to look at? That magnitude is nothing but MdBr again. Okay, so we are taking the phase angle like this and we are going upward like this to find out the MdBr. And the last step is again similar, your K, to find K value, 20 log K is equal to minus MdBr. The final step is same, then you can solve and we will get the K value. This is the K value of the system for which the specified phase margin.